Hello everyone. In this video we will learn about the angle of intersection of two straight lines in two-dimensional coordinate geometry. Also we will learn about the conditions of parallel lines and perpendicular lines. See, when we see here any of the two lines, suppose one of the line is making an angle theta 1 with the positive direction of x-axis and the other line is making an angle of theta 2 with the positive direction of x-axis, then we say for line 1 angle with x-axis is theta 1, it means the slope of the line, that is m1, will be equal to tan theta 1 or not. Similarly for line 2, angle with the x-axis in the positive direction is theta 2 and hence we can say its slope is m2, which is tan theta 2. We already learnt in the previous video that tangent of the angle which a line makes with the positive direction of x-axis is the slope of the line and is represented by small m. Now suppose the angle of intersection of these two lines is theta. We know when two lines intersect there will be two adjacent angles. They are also supplements of each other. If this is theta, this angle will be pi minus theta. So when we talk about theta, if theta is the angle of intersection of these two lines by the theorem of triangle, that the exterior angle of one of the triangle is equal to the sum of the interior angles. Can we say then in triangle, suppose we give that the name ABC. In triangle ABC, we can say that theta 2 is equal to theta plus theta 1. So we find here that theta is equal to theta 2 minus theta 1. If we take the tangent of both the sides, we will find here tan theta equal to tan theta 2 minus theta 1. We know about the identity, that is tan A minus B is equal to tan A minus tan B upon 1 plus tan A into tan B. If we apply this identity here, will we get this is tan theta 2 minus tan theta 1 upon 1 plus tan theta 2 into tan theta 1 or not? We have seen here tan theta 1 is m1 and tan theta 2 is m2. If we substitute that here, we are getting m2 minus m1 upon 1 plus m2 into m1. This can be used as the formula to find out the tangent of the angle of intersection of the two lines. And then by applying this, we can find out the value of theta. But we can see here, if we want to see this angle, then we will find tan pi minus theta, and we know tan pi minus theta is minus tan theta. It means for this angle, here we can apply the sign of minus, and hence we can say that tan theta is equal to plus minus m2 minus m1 upon 1 plus m2 into m1. We can find both the angles by applying this particular formula to find out the angle of intersection of two lines. So we are finding that the tangent of the angle of intersection of the two lines is given by tan theta equal to plus minus m2 minus m1 upon 1 plus m2 into m1. See, suppose we want to find out only the acute angle, because we know these two angles are adjacent to each other. They are also collinear. So the sum of them has to be 180, means they are supplements to each other. So if this is acute, this will be obtuse, and if this is acute, this will be obtuse. Now suppose we want to find out the acute angle. Then we know for acute angle theta, tan theta is always greater than 0. And in that case, this value also will be positive. And hence we can say that tan theta will be equal to m2 minus m1 upon 1 plus m2 into m1. We can apply the modulus for this only to get the positive value. Can we also write this as m1 minus m2 upon 1 plus m1 into m2? Because we are using the modulus sign. Hence we will be getting only the positive value. Why we are using this? Because we like to use the sequence, and here 1, 2, 1, 2 are coming in the sequence, and hence we can also remember this is a formula to find the acute angle tan theta equal to modulus of m1 minus m2 upon 1 plus m1 into m2. After finding the acute angle, suppose we want to find out the obtuse angle, then we can subtract it from 180 over pi and we can get the value of the obtuse angle also. Now we go for the condition of parallel lines. For parallel lines, if the lines are parallel, we know that theta will be either 0 or pi, and we know that tan theta for 0 degree or for pi is always 0. If it is 0, can we say that this also will be equal to 0? It means we are finding m1 minus m2 upon 1 plus m1 into m2 is equal to 0. From this we are getting m1 minus m2 is equal to 0. Or we can say that m1 is equal to m2. It means we can say the condition for the parallel lines is that their slopes are to be equal. Or we can say if the slopes of two lines are equal, then they are parallel to each other. If the lines are perpendicular to each other, then we know that the angle of intersection of them is to be 90 degree or pi by 2. It means we can say that theta is pi by 2 or 90 degree. And we also know that tan pi by 2, which is tan theta here, we know is infinity, or we say not defined. And something is not defined if its denominator is 0. So in that case, tan theta equal to m1 minus m2 upon 1 plus m1 into m2 will be having denominator as 0. It means 1 plus m1 into m2 is equal to 0. From this we get that m1 into m2 is equal to minus 1 by transposing 1 on that side. This becomes the condition for the lines to be perpendicular, that the product of their slopes is minus 1. From this we can also say m2 is minus 1 upon m1. It means if the slope of one of the line is given to us, we can find out the slope of the perpendicular line by the reciprocal of it, changing the sign. Now we will discuss some of the problems based on the angle of intersection of two straight lines. Before going to the examples, if you have not subscribed the channel, please subscribe it so that you get more videos on different topics of mathematics. See here now, the first problem is find the angle of intersection of the lines whose slopes are 1 upon 2 and 1 upon 3 respectively. We find here that the slopes m1 is equal to 1 by 2 and m2 is equal to 1 by 3. Suppose the angle of intersection is theta. Let the angle of intersection of the lines be theta. Then tan theta is equal to m1 minus m2 upon 1 plus m1 into m2. That is 1 upon 2 minus 1 upon 3 whole upon 1 plus 1 upon 2 into 1 upon 3. Take the LCM here. This is 6 and we get 3 minus 2. Here take the LCM as 6. We are getting 6 plus 1. So we get here 6 and 6 are cancelling each other. This is 1 upon 7. So we can say that the acute angle theta gives us the value tan theta is equal to 1 by 7, or we can say theta is equal to tan inverse 1 by 7. This is the way we can find out the angle of intersection of two straight lines. The next example we discuss is find the angle of intersection of the lines AB and BC if A is 2, 3, B is 5, 4 and point C is 2, -1. In such problem, first we have to find out the slopes of the lines AB and BC. So we write here slope of a line is given by the formula we know, that is y2 minus y1 upon x2 minus x1. Here we are given the points A equal to 2, 3, B is 5, 4 and C is 2, -1. By using this particular formula, we can find out the slope of AB, that is 4 minus 3, y2 minus y1 upon x2 minus x1, that is 5 minus 2. So it comes as 1 upon 3. Slope of BC, that is equal to y2 minus y1 minus 1 minus 4. x2 minus x1, that is 2 minus 5. This comes as minus 5 upon minus 3, or we can say 5 upon 3. We can write the slope of AB as m1 and the slope of BC as m2. And then we can apply the formula for finding the angle of intersection. Let the angle between AB and BC be theta. Then tan theta is equal to m1 minus m2 upon 1 plus m1 into m2. Substituting the values, we are getting here 1 upon 3 minus 5 upon 3 whole upon 1 plus 1 upon 3 into 5 upon 3. Simplifying this, we get 1 minus 5, that is minus 4 upon 3, and here 9 plus 5, 14 upon 9. 3 are 9, and we are getting here minus 4 into 3 upon 14. 2, 7. So we are getting here modulus of minus 6 by 7. It means we can say for acute angle theta, tan theta is 6 upon 7, or theta is tan inverse 6 upon 7. Like this we can find out the angle of intersection of the two lines even if the points are given to us. In the next video, we will learn the different forms of the equations of straight lines. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.